Now, towards the end of the previous session, I was providing two reasons, two motivations why it's a good thing to have a formal definition of an automaton. And two were precision, so that allows you to answer questions where things might be a bit ambiguous. Well, here are two, for example. One is it possible to have zero accept states? Can you have an automaton that has zero, doesn't have any accept states? Is that allowed in the definition of an automaton? So if your definition is very succinct and clear and unambiguous and every detail covered in a sense, then you'll get an answer to that question just by looking at the formal definition. Right? So precision is important. And another example, for a given state and a given input symbol, is there only one arrow that goes out, or can you have more than one? Like, can you transition to more than one other state? So that's equivalent. So in other words, say you could transition to two different states. So you'd have two arrows going out, right? So is that allowed? Well, consult the formal definition and you'll find that it is not allowed. Okay? And consult the formal definition and you will find that zero accept states is allowed by the definition. Okay, so precision is useful. So there's no ambiguity. That's part of the point. And notation, like I was saying a bit before, having a standard notation so everyone can describe an automaton to other people. They're all using the same notation. It's like musicians, they all use the same notation for writing down music on paper, so other people can read someone else's music written by someone else, stuff like that. So a standard notation. So and good notation, that makes sense. So good notation helps clear thinking when you're writing down your description of an automaton using this standard, precise definition, a formal definition. Okay? Alright, well, let's start thinking about the definition itself. What would we put into it? Well, we have a pretty good idea already. We've already got a pretty clear idea on what an automaton is. So think about it. Let's make a list of the parts that an automaton has, its parts. So one would be a set of states, right? So you list the states. That would be an obvious thing to do. Okay, and then you need transition rules of the type given that you're in state, given state, and the input symbol you're reading, the automaton is reading, is of a given kind, then transition to a different state, or maybe in the same one. But yeah. So current state and input symbol, then transition to some other state. Okay? So you need a set of transition rules, or if you like, the state transition table. Okay? So that's the third thing. What else? We need to know the start state, right? The one with the disconnected arrow to it. So that's a fourth thing. We need to know the start state. And what else is missing? We need to know the set of accept states. Okay, so we list the states, the state names, the names of the states that are accept states. Now, so far I've only talked about one automaton and it only had one accept state. But you can have, you could have more, larger, more complicated automata that have more than one accept state. So you need to list those states that are accept states, right? So those 5 things, and that's it. Now if you can list those 5 in a mathematically precise way, which we'll do in a minute, then you have your definition of what an automaton is. Okay. So the formal definition is a list of these 5 things. Okay? And just refreshing again, what are those 5 things? Set of states, an input alphabet. What does that mean? That means the allowed symbols you can have in your input stream. Okay? So an input alphabet, that's what that means. So an alphabet just means a set of allowed symbols. So before we had a binary alphabet, so the allowed symbols were just 0 and 1. Okay? So an input alphabet. So an alphabet of allowed symbols in your input stream. Right? And rules for moving the start small. That's alright. That's wrong. That should be current state. Current state. Okay. So in other words, the rules for state change, for making a transition from your current state to the next state. Okay. So the state transition table, in other words. So that's your 3rd thing. List a set of accept states. Wait a minute. Oh! You see what I've done? I didn't see this comma here. So it's just rules for moving. That's a bit of a shorthand. In other words, the state transition table, comma. And then of course this would be the start state. Okay. Yeah, that one little comma. I mean, how many wars have been started due to commas and that's a classic misinterpretation. Interesting. Okay. Okay, so the 4 things. Okay, set of states, an input alphabet, the state transition table, if you like, the start state, and the list of accept states. Okay. So 1, 2, 3, 4, 5 things. So we have a list of 5 things. We have a set of 5 things. Now, you probably remember from a previous chapter, a list of 5 things tends to get labelled a 5 tuple, T-U-P-L-E. Okay, so our formal definition then will be in the form of a 5 tuple. The 5 things I just mentioned. Now, the state transition table, that gets described more precisely in mathematical terms using something called a transition function, written here as delta.